Welcome to Chapter 2, Section 4, Fitting Linear Models to Data. The first thing that I would like to discuss with you guys is drawing and interpreting scatter plots. You guys have seen those before. They're like the diagrams that have like the graphs that have like all the dots everywhere. Let's go ahead and head on over to Desmos. Love Desmos. And we are going to enter in a table. And to enter a table in Desmos, you just type table and this will pop up. So I am going to create a scatter plot of the number of chirps that a cricket makes is X, and the temperature is going to be Y. So we're going to have 44 and 80.5. 35 chirps when it's 70.5 degrees. We're going to have 20.4 chirps when it is 57 degrees. 33 chirps when it is 66 degrees. 31 chirps when it is 68. And then 35 and 72. 18.5. 52 and 37 and 73.5, and the last one is 26 and 53. And you're going to want to do this because there will probably be a scatter plot question, of course, and you'll be able to use Desmos for it. Okay, so I'm going to zoom out and move over to a point where I can see all of my chirps. There's all my chirps. So what I am going to do now is I am going to find the line of best fit. But first, I'm going to want to talk about what the line of best fit is. So this is when we plot values of differing variables. Let me go ahead and correct this. So of differing variables on the X and Y, we treat them as ordered pairs. So you will see that usually they're given as a table. Or a list. So now what I wanted to talk about in particular is the line of best fit. So the line of best fit is a model where it creates a line, of course, that best fits the data. So if you've ever heard of like linear regression or least squares, though this would be like line of best fit. So I am going to go back to Desmos. Here we go. And let me see if I can remember how to do this. I think it is going to be Y, where's my tilde? Y tilde X underscore 1 M plus B? No? Try Y underscore 1. There we go. So it's Y underscore 1 tilde X1 M plus B. Don't worry about residuals. Nobody cares. So if you wanted to give me the graph of this line, your M is right here, your slope. So that's what you would substitute into M, and your B is what you would substitute into B. So this is the x-intercept, this is the y-intercept, and this is the slope. Now R, that's a really good one. This is called the correlation coefficient. which means that it determines how well things correlate. Let me get back into here. So the line of best fit. Let me just, you type y sub 1 tilde x sub 1 m plus b into another line in Desmos. So that's a little note for you guys about how to do that. This fits the data to a line that approaches the data like a function would. So that if we had to predict something, we could reasonably use this line to predict it. So I'm going to go back here and I'm going to show you what happens. Let's see if I can move one of these. No, I cannot. Well, let's do 2 points that maybe we can move. No, I can't do that. Well, if I could show you, what happens when you move these points is this line that you see here will actually change. This line itself, it will change and it will move in order to fit those points well. If it's really spread out, it actually won't fit them well at all. So one thing I want to talk about is the correlation coefficient, which is little r. So this tells us how well the data will fit a particular line slash trend. So, because it also works for parabolas. Now, the closer r gets to 1, the better the data fits the line. That means they have a very strong relationship because they correlate well. The closer r is to 0, the less correlated and more chaotic the scatter plot will look. So when r is positive, it is a positive trend. When r is negative, it is a negative trend. So here you'll have, let me get a pen. So you will have zeros in the middle, right? So if we had a scatter plot, it would look just like, it would, no correlation at all, none whatsoever. And this is r equals 0, 0.0. So when r equals negative 0.5, it'll be, you can kind of see the trend going down, right? Well, when r reaches -1, that's a very, very strong trend. See, it's a line pretty much. But if we were to go in the other direction, so if r were to equal positive 0.5, you'd get something like this. Kind of an upward trend. Now if r was equal to 1, you would get a very definitive trend going upward. And if you notice, the r is 0.95 here, and if I take away that line, it is a very obvious upward trend. I would say they have very high correlation between the number of chirps and the temperature outside. It appears that as the temperature increases, the chirps increase. We could say as the chirps increase, the temperature increases, but that kind of implies that the temperature gets warmer because the cricket is chirping, and that's just not true. So you could say, the warmer it gets, the more a cricket chirps. And in terms of interpreting these sorts of things, these are the major concepts that I just wanted you to pick up from this chapter. You will be asked to do this, so be sure you understand how to use Desmos. And that wraps it up for Chapter 2. Thank you.